Wasteland Coder here again, and today we're going to take a look at a typical interview question. And that's going to be to sum the digits of a number. So if we have a number like 32, what we need to do is split out the digits, 3 and 2. We need to add those and come up with the answer 5. And it can be a 2 or 3 digit number, anything like that. We should be able to just take it, split it, and add the digits. So we're going to take a look at this in true test-driven development fashion. We're going to start with a test. So we have our test here. We have a just stubbed out class here. Interview digits test. And so this is just simple setup in here. It's going to be a JUnit 5 test. And so we're just going to add our first test method. And that's just going to be, well, where's a good place to start? How about splitting the number that we get into digits. And so we can start with a test like this. Of course, this isn't how you'd actually start your test. It would look something... No, this is a good way to start the test. Just write it out. We're going to instantiate a new interview digits. We're going to call it system under test, or SUT here, just for ease of usage. We're going to set up a new array list that's empty, put some digits in it that we expect, and then just call some method that we're going to make up, split to digits with a number 149, so those digits split up should be 1, a 4, and a 9. We're using a list instead of a set or anything, because we want any duplicates, we want to preserve those. So if you had a number like 111, you want all 3 of those digits instead of just 1, which you'd get with just a hash set. So that's why we were using a list here. So then we're just going to check that what we expect is what we actually got. So then when we go to our class, first thing you want to do actually is make sure this test gives you a failure. So when we run this, we get a failure that looks something like this. Cannot find symbol, split to digits. Okay, that's what we were expecting. So then we come over to our class, and then we need to write a method. Of course, our method's going to look like this, but that's not what we're going to start with. What we're going to start with is just something that returns null. That's the simplest thing you could write to get past the broken failure. So when we run this, we get an error that looks like this. Assertion failed error. 941 is not null. Okay, that's what we expected. So then we can go on to flesh out this method itself. And when we do that, it'll look something like this. We're going to instantiate a new array list that's empty to hold our digits. We're going to be interested in the tens spot. And so what we're going to do is, to our empty list, we're going to add the number modulo 10. So that's going to get the digit in the 10 spot. So with our 149 number, it's going to grab the 9 first. And we're going to add that to the list. And then we're going to divide the number by 10, and this is integer division. And so that's just going to chop off this last digit here. And it's not going to leave a decimal place or anything. That's why it's integer division. And then we're going to do this while the number is greater than 0. So the number now is 14. That's greater than 0. So we're going to come back in. Modulo 10. It's going to be the 4. Divide by 0. But divided by 10. We're going to get 1. Do it again. Add the 1 to the list. Divide by 10. It's going to be 0. 0 is not greater than 0. So return our list, which is now 941. So then when we run that, it passes. Yay! So now, one of the places that we may get tripped up here that we might want to check is if we pass in 0. That's an interesting case. So let's maybe check that. We'll have to see. Oops. Add this back here. Actually, before we add test 0, what we really care about is just that we have these three numbers, not the actual order of them. But here we're checking that the list actually equals 941. So one thing that would be nice to do would be to check that it just contains those numbers that we expect. So here, just check that digits contains all of the numbers that we expected. And then we give it a nice error message here if it fails, so that it looks pretty rather than just expected true but got false or some other error message like that. So if this were to fail, it gives us something like this: expected a list containing 941 but was empty list. One place that may trip you up here with this version of the test is if digits is null, like we started with. You'll get a null pointer exception here, but that'll still fail your test, so that's kind of okay. So now we can move on to testing with 0. So if we add that method here, test split to digits with 0, we just do everything like we did before, except just pass in 0. We expect 0 back, give it a nice error message, and when we run that, it does in fact work. Okay, so we have green now. Happy, we don't need to refactor any further. So let's add the next test. So the next part will probably be to actually add those digits that we just got. So we need to write a method that will add a list. That seems pretty simple. So what we'll do, if I can get it all on the screen, just take the same thing we did before, very similar. We're going to set up a list like we would have gotten out of the one before, of the split to digits method. Just expect 14, 9 plus 4 plus 1, 14. Just call a new method that we're going to define called sum. The list that we want to add up, then just expect 14 equals 14. Should be good. Of course, if we start with this, we'll end up with a broken test because sum does not exist yet, cannot find symbol, so we have to go write that method. So if we come back over to our class, interview digits, we need to add that sum method. Of course, we're going to start with something that looks more like return null, except in this case, because it's an int, we can't return null. Primitives can't be null. So we're going to just return the default, which is going to be a 0. If we run that, it's going to fail, like we expect. Expected 14, but we got 0. Okay, now we have to write enough to get that to pass. So we're going to just take the list that we get in, loop over it, start with 0, and just add them all together. Do the plus equals to add the number to the current sum, and then assign that back to sum, and just return sum. Yay! If we run that, come up with good. All of our tests pass again. So it's time to do the next piece. Back to the test. So in our test, the last little bit that we need to do, if we push all this up a little bit, is write a test that actually combines the two pieces that we just worked on. So this is going to be a new method called digit sum that we're going to pass in just an integer number and expect it return the integer sum. So if we pass in 6 and 5, we could have done 941 again, but wanted to change it up. We expect 6 plus 5 to be 11, so just assert equals. If we run that, of course it's going to be broken. We haven't written digit sum method yet, so we need to go back to our class, write the method that's going to return 0 or null, 0 in this case because it's an integer again, and you can't see it. So that should get us past the error, and now we just get a failed. 11 does not equal 0. Okay, so we can move on from the return 0 and actually do the work, which is a simple one-line method. We're just going to call split to digits on the number, which will give back a list, and then we're going to just pass that to sum, and then return that. When we run that, it's good. All of our tests pass. There's much rejoicing. Last thing we can do is just add a simple main method so that we can print out the answer to the console, just for fun. So we're going to define a number to work on, 65, instantiate a new interview digits because none of our methods are static, and then just system out println interview digits dot digit sum, which is the method we just wrote, pass in the number, and then it'll spit out 11 to the console. Yay! Thanks for watching. See you next time.